Hello everyone, I am Evolution World. In the long evolutionary history of animals, various extinction events have been like a recurring motif, arriving unannounced. Among these, 17 were minor extinction events. We've previously discussed events like the Carboniferous rainforest collapse, the Ordovician extinction, the Carnian pluvial event, and the Paleocene-Eocene thermal maximum, all falling into this category. For those interested, you can check out videos on these topics. Then there are 4 medium-scale extinction events: the late Ordovician extinction, the late Devonian extinction, the late Triassic extinction, and the late Cretaceous extinction. Look at these extinction events, each one brought about widespread devastation and a complete turnover of dominant life forms. However, towering above all these extinction events, there was only one true mass extinction event in the history of animal evolution. That is what we will discuss today, the late Permian mass extinction, commonly known as the Great Dying. This event single-handedly wiped out 95% of all species on Earth. So, what exactly caused such immense suffering to life on Earth? Simply put, over 250 million years ago, due to continental drift, all of Earth's landmasses converged to form a single, vast supercontinent called Pangaea. With so much land bumping and grinding together, it inevitably led to geological stress and friction everywhere. Consequently, Earth entered a period of the most intense volcanic activity since the dawn of animal life. Finally, 260 million years ago, Earth's geological tension reached its limit, and a cataclysmic doomsday event unfolded. The first wave of molten fury struck near what is now Mount Amei in Sichuan, China. Here, a supervolcano suddenly erupted, unleashing immense rivers of lava. In an instant, it annihilated every forest within a 100-mile radius, transforming the Sichuan region into a realm of hell. After the widespread flowing magma cooled, it solidified into dark basalt, leaving behind layers of dark rock in the strata, recounting the horrors of this ancient inferno. Thus, this initial large-scale volcanic activity is known as the emission traps event. Volcanic activity of this magnitude, in any other era, would have been enough to trigger an unprecedented mass extinction event. However, for the late Permian, this was merely the prelude to a series of cataclysms. 9 million years after the emission traps event, an even more violent volcanic eruption occurred in what is now Siberia. Known as the Siberian traps event, this finally pushed the vast majority of life on this planet into the abyss of no return. If an alien had approached Earth at that time, they would have been met with a terrifying and shocking sight. The planet would have appeared as a colossal corpse suspended in space. Its surface, as if torn by the hand of death, would have seen horrifying lava, like viscous pus, bubbling and pouring out from the enormous fissures in Siberia. This was accompanied by a putrid, deadly smoke that permeated the entire atmosphere, shrouding the entire planet in a deathly silence. In this relentless, hellish outpouring, lava was merely the first wave of destruction. What truly annihilated life on Earth was a gas produced by the volcanoes, sulfur dioxide. Sulfur dioxide in the atmosphere would react with oxygen and water to form sulfuric acid, which then fell to the ground as so-called acid rain. Living beings exposed to it would either die or be severely debilitated. Seeping into the ground, sulfuric acid would also contaminate the soil and groundwater, rendering the land barren for decades. But this was not the end. Sulfur dioxide would also bring a third wave of destruction. The sulfur dioxide in the atmosphere would create an anti-greenhouse effect, the opposite of carbon dioxide's warming. For a time, the planet would be plunged into a global ice age, with sea levels dropping dramatically, and finally, concluding this doomsday judgment, came the volcano's other deadly gift, carbon dioxide. As the sulfur dioxide gradually dissipated, carbon dioxide began to dominate. On one hand, high concentrations of carbon dioxide itself could potentially cause carbon dioxide asphyxiation in bottom-dwelling animals. On the other hand, its powerful greenhouse effect caused global temperatures to rise sharply, throwing all of Earth's oceans into turmoil. This chaos led to ocean anoxia. Furious ocean currents stirred up rotting organic matter from the seafloor. Under the action of bacteria, These substances rapidly depleted the oxygen in the seawater. What remained was a desolate, empty Pangea supercontinent, scorched by heat and drought, utterly devoid of life. The vast majority of life was pushed into isolated coral refugia, and lush rainforests became a distant legend. In some oceanic regions, stromatolites, structures built by algae and bacteria, even reappeared, as if life had traveled back to its earliest beginnings. Yet, for some unknown reason, a few animals remarkably survived this cataclysmic event. In this series, we've mentioned that our mammalian ancestors, at the very last moment before the mass extinction, completed their second physiological revolution, evolving new features. For example, their nasal cavities, lined with mucus and cilia, could, to some extent, filter out some of the toxic dust. These subtle differences in toxin resistance sometimes meant the difference between life and death in the wasteland. Furthermore, constant body temperature was an even greater survival advantage for our mammalian ancestors. Within a certain range, for every 10 degrees Celsius increase in body temperature, metabolic reactions and strength roughly double. Around 37 degrees Celsius, an animal's body functions can operate at their peak. Being warm-blooded meant that an animal's body was in a state of perpetual peak performance. In this unpredictable environment, absolute strength was the ultimate truth. At the same time, these resilient mammalian ancestors meticulously developed every possible sensory modality. Some of the hair on their faces evolved into sensitive whiskers, capable of detecting minute vibrations in their surroundings. A part of their maxilla, upper jawbone, and 2 parts of their mandible, lower jawbone, gradually shrank and migrated into the inner ear, connecting to the eardrum, making their hearing increasingly acute. Not to mention their already very powerful sense of smell. Each additional sense provided an extra layer of protection. From then on, whether in darkness or amidst overwhelming stench, no harsh environment could prevent our ancestors from finding the slightest glimmer of life. Complex sensory input also necessitated a more sophisticated nervous system. The advantage of warm body temperature, in turn, ensured the proper functioning of their bodies. Thus, our ancestors expanded a 2-layered structure in their forebrain, the paleocortex, into a 6-layered structure. This gave rise to a groundbreaking creation, the neocortex. The emergence of the neocortex was akin to adding a high-frequency, multi-core, multi-threaded processor to the animal's brain. This allowed our ancestors' sensory perception and cognitive abilities to make a qualitative leap. Over the next 200 million years, this would enable mammals to thrive for generations and expand their territories far and wide. Consequently, the therapsids, represented by groups like the cynodonts, successfully endured the crucible of the Great Dying. Through this series of hardships, they developed a brand new group called mammaliaforms. However, in my opinion, the most profound impact on future animal life came from another revolutionary change, a measure that both the archosaurs and therapsids, mammal-like reptiles, adopted concurrently, have fewer offspring but nurture them well, ensuring a lifetime of success. A group of archosaurs, the Archosauromorpha, began to rise. Their eggshells became increasingly hard, offering excellent protection to the developing embryo. Inside, a large yolk provided sufficient nourishment until the embryo was developed enough to face the harsh world. Sometimes, even after hatching, these archosaurs would continue to care for their offspring, mammaliaforms, with their less developed amniotic eggs. Didn't have such conditions. Instead, they adopted a different strategy. On one hand, they kept the eggs inside the mother's body for as long as possible, delaying the formation of a hard shell. This allowed the mother's body to absorb the embryo's urea and also provide some nutrients to the fetus. This evolutionary path ultimately led to the development of live birth in their descendants, the mammals, over 100 million years later. However, even with these adaptations, the newly hatched mammaliaform young of that era were, by today's standards, still premature. Yet, some mammaliaform mothers began to invest an extraordinary amount of energy into caring for their young. This, in turn, laid the foundation for the later emergence of mammalian nurturing behavior, when heaven and earth were merciless, sweeping across all living beings like a cap of destruction. Animals, embracing a faint warmth, proudly stepped into a new era. Let the sufferings of yesterday nourish our glory tomorrow. Today's lesson ends here. Don't forget to leave one like, one share, one comment and one channel subscription. Thank you very much.